Okay, so in today's video we're going to be talking about a solar panel. What is a solar panel? A solar panel is the energy converter that converts sun's energy to electrical energy that we want. It is made from small elements called solar cells. We are not going to talk about the physics part of the solar cell itself, but we are going to start from a number of cells joined together to make up a solar module or a photovoltaic module, which is known as a solar panel. A solar cell, up to this day, the efficiency of a solar cell ranges from 14% up to 26% for the latest technologies. This means for a 1000 watts per square meter insolation, a 1 square meter solar panel that has got, for example, an efficiency of 15% can only produce 150 watts. Now, I've said you're going to be concentrating on photovoltaic modules, which are, of course, made from solar cells. A photovoltaic module is the energy converter, and this is the gadget that takes the sun's energy and produce the electricity energy that we want. If we join a number of solar panels, 3, 4, 5 will make up a string, and depending on the correct connection that we would have made, series or parallel, we would then end up having an array of solar panels. What is of importance when you want to choose a solar panel is what is written at the back of every solar panel. For example, if you were to check every solar panel, it has got a data sheet that is at the back, and it is this data sheet that I will explain a bit of what every entry or more important entries that are there means. We've got the size of the module in watts. You will see that there is output power in watt peak. What this means is at the maximum, that panel, at maximum insolation, that solar panel can only give out that maximum power that is given. For example, a 330 watts solar panel can only give 330 watts at maximum radiation. I'm emphasizing at maximum radiation because this power can reduce depending on whether it is cloudy, it is clear, or it is average. So it will range, but the maximum power that it can give you is 330 watts. You also see that there is an entry that is written short circuit current. Short circuit current is the maximum current that you will get if you were to short the terminals and record the current that it will produce. And this is also when we are using an insolation or radiation of 1000 watts per square meter. There is also an entry called VOC. VOC simply means voltage at open circuit. If you were to measure the terminal voltage of the leads that comes out from the module at maximum insolation, this is usually between local noon, you would get the voltage that you would get at that time is what is referred to as VOC. There is current at maximum power point, or IMP. Current at maximum power point, what we are saying here, we are saying every module has got an operating curve, or an IV characteristic, a combination of current and voltage that it follows. So IMP and VMP refers to the point when that solar module is doing its best, or it's giving maximum output possible for the given radiation and the given solar module. It is from that IV curve that maximum power point trackers tends to optimize by finding a point along the IV curve of a solar module that will ultimately help the module give its maximum power. There is a temperature coefficient. A temperature coefficient, it can be current temperature coefficient or voltage temperature coefficient or power temperature coefficient. Current temperature coefficient is positive. What does that mean? It means with the increase in temperature, the current increases. And this is coming from the physics of the solar cell. I'm not going to be talking about that, but just know that with the increase in temperature, the current that the module outputs increases. However, the voltage reduces with increasing temperature. So ultimately, because the power is equal to voltage times current, it means power reduces with increasing temperature. And that is important because that will then hint that whenever you have to mount a solar panel, you have to make sure that it's not going to overheat. Because once it overheats, it means the performance is going to reduce. Rather, the output that is going to give is going to reduce with the increase in temperature. Therefore, it is always encouraged that when you are mounting solar panels, you elevate them a bit or you allow free air circulation for the purpose of cooling. The lifespan of a solar module is expected to be around 25 years. And most manufacturers always give a warrant of 25 years, and it is expected that for these 25 years there will be minimum degradation. Of course it will be there, but very little, such that it is insignificant. There are types of solar panels. There is monocrystalline, there is polycrystalline. People have often asked which one is better, a monocrystalline or a polycrystalline? Right. The answer depends on what you want to achieve or how you want to use the solar panel. Otherwise, if you are given a 330 watts solar panel, whether it's polycrystalline or it's monocrystalline, the output that is going to give you is the same. Contrary to the thinking that a monocrystalline will give you higher output. However, if you now check the size of those solar panels, the 330 watts polycrystalline and the 330 watts monocrystalline, you will see that the monocrystalline is smaller than the polycrystalline. This means that if you buy a monocrystalline, you are going to save on mounting space. And suppose one is to build a solar farm where they only have a limited space and they want to harvest as much as possible. It is in that case now when possibly one would go for a monocrystalline solar panel, because they are going to mount a lot of solar panels on a small space to give a much bigger output. In other words, the only advantage that monocrystalline will have versus the polycrystalline is that of space saving. If you've got a small roof and you want to maximize output, then you're going to go for polycrystalline. Otherwise, in terms of performance, once a panel is made and it's tagged or it's marked 330 watts, that's it. It's going to be 330 watts and it's going to give you 330 watts at 1000 watts per square meter insolation and 25 degrees cell temperature and 1.5 air mass ratio. That is very important. Every other panel is, or every other datasheet is given according to STC standard test conditions. In other words, a 330 watts is a 330 watts at 1000 watts per square meter at 25 degrees at 1.5 A mass ratio. A mass ratio is just a measure of how far would the wave have traveled through the atmosphere and the sky. So for today, we are going to end here with this video. Thank you for watching, and please share and press the subscribe button. Thank you.